A very good morning to all the participants. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for the second in the webinar series of Information Technology and Operation Technology Integration for Man, Machine and Material Connectivity. This is the second in the webinar series jointly with Maxbyte Technologies. The session is organized under the aegis of Industry 4.0, chaired by Mr. A.N. Chandramouli, Chairman and past President of the Chamber, and co-chaired by Mr. Jagannath, who is the COO of BFW M2 Next subsidiary. Today we have with us Mr. Sabarinathan, who is the Vice President, Strategy and Innovation at Maxbyte. Thank you very much, sir, for accepting the invitation to address at this session. The Chamber acknowledges its support to all our annual sponsors for their immense support in the activities of the Chamber for the whole year. I would like to briefly introduce Mr. Sabarinathan. With over 15 years of experience in digital transformation, he leads strategy and innovation at Maxbyte Technologies, specializing in Industry 4.0 solutions. He drives the development of cutting-edge solutions and oversees digital transformation, consulting, leveraging data and analytics, and augmented reality. As a former chief product officer, he has defined the product vision, a roadmap, and features for digital manufacturing and Industry 4.0 platforms. He helped business achieve operational excellence and competitive advantage. He holds an MBA in systems and marketing and is an engineering graduate in mechatronics and robotics. Thank you very much for all the participants for joining at this knowledge sharing session. And over to you, Mr. Sabarinathan.
Thank you, Roopa Madam, for the kind words. And I thank the BCIC team and all the participants for taking interest in a Monday morning to attend this webinar series. So just a brief about our company. So we are into Industry 4.0 implementations for the past 8 years. We have implemented small and large projects across India and globe. And with that experience and also my experience, we would like you to share some of our knowledge on OT-IT integration and why it is important and how it will help. So I will just go through it, and please, if you have any questions, you can put it on the chat window, or we can let me know, and I think the moderator can push me for the question. Thank you. So today's agenda, we will see what very brief of industrial IoT. I think the first session on Lean 4.0, you will know what is Industry 4, what is IoT, etc. We'll just touch upon what is industrial IoT. We'll see what is operational technology. So it is what it means and how it has, how is it important for Industry 4.0. We will see the evolution of OT-IT convergence. Who are the key stakeholders involved in enabling this OT-IT convergence, and brief examples of how to implement OT-IT strategy and what are the challenges and global trends involved in it. Thank you. So this is a very brief. I will just not go into depth into this particular section because we have other sessions on this and we are also briefed over this. So generally, if you take IoT or industrial IoT, we will have a lot of devices that sense data. This data is about conversational or contextual awareness of the equipment or the process involved, and these data which are being received in multiple formats, it is actually collected through gateway devices and a server, edge server, and it is sent to a on-premises or a cloud server where we have the IoT platform and applications which has the multiple level of apps based on the user scenario, which gives the complete convergence of the physical and the digital world. So this is a brief. In that, what is OT and IT? So OT is nothing but all the equipments that are there, the actual equipments that are producing are involved in the manufacturing. It may be the CNC machines, it may be the forklifts involved, it may be a complete paint booth, etc. It involves all these components. Along with that, the control systems, the controllers, the all the edge industrial hardware and software is needed to for that equipment to operate its actual process. So IT is nothing but the all the enabler of OT and also helps the factory run according to the customer requirements on keep the systems on track. We have all the ERP, CAD, PLM, the maintenance modules, etc. Everything considered this. This structure that you are seeing, this architecture, is called ISA 95 architecture. So ISA 95 is an ANSI standard, which is for integrating enterprise and control systems in manufacturing. So you can see that there are L0, L1, and L2, which is nothing but our OT layer, which has all these smart connected assets, sensors, instrumentation, and control. And over that, we have the operations, like we have the production systems, the quality systems, etc. And the L4 is the IoT enabled business systems, which is integration with our ERPs and other systems. And the last is IoT enabled governance and planning systems, wherein the complete planning can be done. This is the most advanced level. So this is published by LNS Research in collaboration with ANSI standards. So on a typical architecture level, if you see the physical level is where all you have the sensors, actuators, the communication hardware, and all the processors, etc., which are directly in connection with the actual industrial assets, which collect this information. And over and top of that, we have other industry 4.0 assets, like we say the RFID tags, barcode readers. We are having like some of the beacons, sensing solutions, industrial robots, etc., which operate in parallel or in coherence with the actual assets. And if you see in any factory, there are say n number of assets have operating on different kinds of protocols. So in the communication level, we are using devices to collect all these protocols through various approaches, which we'll see in this session. And the aim of this communication level is to collect all this information and present it as one true source for any IT system. So the data that is collected is presented to the system level for various platform processes and all, etc. On the final end user level, we see the applications, which is actually what we are using. But under that, so many activities are being done. This is a basic level. We'll come back to this structure again. And going deep dive into OT. So OT is a hardware and software that is involved for direct monitoring and control. These are all various definitions, but to simplify, it can be simply called as all the assets that you see in person in a factory, and all the hardware that is placed on top of the assets, like the PLCs, the controllers, etc., which helps the asset to operate, and all the other sensors and actuators that we add as part of Industry 4.0, and also protocol converters, etc., and collecting this all information and presenting it at an edge level in the sense at the machine level or at the factory level, just before it is being sent for processing. This entire system is called OT layer, and this is another. These are some of the components of OT. So, like I said, the actual asset. Then we have the PLCs. The RTO is the remote terminal units. The HMIs, where there are HMIs as part of the machines itself, are there. We are adding some HMIs as part of IoT systems. for helping users capture, say, downtime, using barcode readers to capture the asset or RFIDs, etc. All these under that. Then we have the master terminal unit, which completely controls, and the protocols involved, and also some safety information systems that is used for security, etc. All these together form the OT elements. And sensors and actuators in a traditional manufacturing scenario, there are some inherent sensors that are there on the assets for it to perform. But when coming to Industry 4.0, most of the time this information is enough, but we need more information. For example, if you have say an hydraulic equipment or a motor, you want to monitor a vibration of the motor itself as part of your improvement program. The data that is already there in the motor is not sufficient, and you present with like a vibration sensor and sound acoustic sound sensor or a temperature sensor, which collects the information. This information is overlaid on the motor performance itself, and we are getting, this is just one example. So likewise, these are all the sensors that we add on top of the existing system to collect more information for better performance, higher throughput. And also in the sense of actuators, say if you want to go one level above, if you want to physically using smart technologies control the process itself, when we are going to create like kind of a self-correcting systems, then we need actuators. These can be as simple as like a pneumatic actuator to like valves that can be controlling the flow of liquids and other components, as complicated as like robotic arms, conveyors, etc. So all these together also comes part of the OT element. So you might be knowing in all the factories, it is not like one machine that is giving all the output, or one make and model that is present. So throughout the entire factory, to right from the raw material inward to the finished goods outward, so many equipment are there. There are, say, there are CNC machines, there is a paint booth, there is a shot blasting machine, there's a welding, simple welding machines, and so many machines are involved, and the makes and models are completely different. So for that, for the OT purpose, we simply classify into these four. We put it into one of these four buckets. So conventional machines are like typically the machines that are from the early ages, which are still being used, which do not have any PLCs or controllers, or it uses a very old simple PLC which do not have any communication protocols or communication itself. So it is just powered by electric drives and machines, motors. That is all the conventional machines. And special purpose machines are those machines that have PLCs and automation, and which these PLCs we can know the different status of the machines, and we can also interface directly or through some protocol converters. CNC machines, which are all the modern machines with the CNC drives, these can be as well multiple makes and models. It can be Fanuc, it can be Siemens drive, or it can be Mazak or Heidenheim, etc. So many varieties are there as well. And the last one is all the advanced ones like industrial robots, which are used for like the pick and place, or it can be like a cobot arm, or it can be like a welding booth, or it can be a paint operating. All the industrial robots, which can be also information can be obtained and controlled. So extending to the previous slide, so what are the challenges in OT infrastructure? So like any factory, the diverse assets are there, different makes, different OEMs, different models, and different versions of softwares, etc. And multiple protocols are involved. There are n number of protocols, and there is a purely a very challenging environment, and these assets are in like limelight, and they're all part of critical infrastructure. Any any outage or even any planned maintenance for connectivity, etc., requires lot of planning because the production process is being stopped. And some of the scenarios, there is either the machines are old and there is no vendor support, or the AMC is not there, or certain scenarios the vendors lock their machines with protocols and they require license for accessing it, etc. And all these are part of the challenges. But when coming, what are the need for OT/IT? Need for OT modernization is primarily like to data is critical for today's scenario, and we need right data at right time. And historical data helps in prediction and improving the systems, and also remove dependency on information silos and people involved in collecting data, avoid human errors, etc. There are all these. We know what are the uses of connecting and modernizing this OT. So there are some barriers in modernizing this because in most of the scenario, these are all capex investments. The right amount of funding is not there for investing in machines and hardware. And certain scenarios, system is still performing and it has not reached its end of life. And also in a finance perspective, the full investment returns has not been realized. And there are scenarios where modernization will not result in significant benefits. And there are other priorities in the factories that is permitting to improve these current assets. And also management, or there is a perception that a non-connected asset is a more secure asset than a asset that is connected. So these barriers needs to be overcome for it to be modernized. So with that being said, what is the approach? We should have a complete strategic alignment for primarily what is the approach needs to be there, and build a roadmap. So this strategic alignment and roadmap defines the key processes like what is the objective, which we have to identify what are the pros and cons of data collection. We have to identify uh, what is the outcome that we are expecting, and based on this we build a multi-year roadmap and phase two roadmap. Then we focus on some critical assets and critical processes which are bottlenecks in the factory, and focus on that, realize outcomes, and then go on to next set. That being said, when we have to do is a complete assessment of the existing infrastructure. There are various methods and the various parameters to be considered: the make, the OEM, the make and model, the type of controller involved, the data parameters that needs to be monitored, what is there possibility of taking data, etc., and what will be the architecture that needs to be implemented, how the even if you say then what is the network architecture, whether we are going to connect all the assets using the Wi-Fi or through physical Ethernet cables, and what will be the cost of that, etc. And then over to the next level is like, once we are able to collect this information, how are we going to collect the information, what software we are using, what tools we are using, what will be the policies of storage, policies of retrieval, etc. And then the key aspect is planning for the overall security, how we are isolating the factory environment with the OT and IT environment, etc. And like I said, with the whole strategy in place, we start small and expand it to the complete architecture. So the OT security is very much needed. Even there are challenging scenarios which have resulted in blockages in like even in top companies, but uh, it is something that we need to take care actually. So it is as good as taking precautions is more important when it comes to OT security. We need to collect data, but at the same time, it is essential we take all the precautions. So we have to comply with standards. We have to define proper network structure. We have to have proper isolations of network. We have to have the concept of demilitarized DMCs and how it can how data flows there. And some of the scenarios we have to take concurrence with the customer data and keep that as well as in mind. And we have to comply to all these standards. So the most used processes like identify what are the threats that are there, protect it from those threats, and detect if there are any threat that has occurred or it is going to occur, and if it has occurred, how it has to respond and how we are recovering. So there are scenarios like what we call as self-healing mechanisms. There are structure and software. If say a machine is identified as an kind of up, uh, kind of some security threat, the system puts the machine in complete isolation so that further systems are not getting machines are not getting affected, and their proper procedures are happening to remove the threat. Self-healing happens and it comes back to the network. Those kind of advanced levels of OT security is currently available, and there are different things. This is altogether a different topic, but I'm just giving the high level information. There are different scenarios and different strategies we need to follow to ensure OT security. And so far we have seen about OT. Now, why is it required for IT? So IT is, like I said, is the support process of the whole factory, but IT drives the overall business, and OT is what which is actually producing or something. So if you see the OT IT convergence is very keen because earlier OT could happen separately, IT could happen separately. There were so many peoples and so many papers involved. Manual plans were drawn, manual reports were generated. But in current scenario, even I would say when we started using ERPs, already the OT IT convergence has begun. And now in the current scenario, it is even more prevalent when we are monitoring the actual process. We are going to see like how even if the part goes to the customer premises, how it is traced down to the each process, etc. The OT/IT convergence is very important for now. This is self-explanatory, but overview is OT and IT are slightly different, not slightly, it's completely different, but it is both are crucial for business. The standards followed are different. But if you say, for example, uh, say, consider how often the IT assets are being, uh, there are software changes or there is batch updates, etc. IT, it is more prevalent even as a weekly basis. But if it's same scenario, if you take for a CNC controller, it is hardly ever been changes are made by vendors, and even if it is made, it is like once in 3 years or 5 years, etc. And the processing power is totally different, and life cycle is as well. IT life cycle is very small compared to OT life cycle. This is what I was explaining earlier on the OT/IT convergence, how in the various periods, how it has enabled. So if you see, earlier it was completely islands and silos. Over the period of time with most like the early 2000s, the internet, the ERPs and the MES, etc. We have started to use an integrated architecture, and we have this 5-layer architecture which we follow, and there is even you can see different modules with seamless integrations. So in going forward, there might be even more convergence, like IT going to the OT layer and OT going to the IT layer kind of thing, wherein we are using like say virtual drives and controllers for the machines, and say we are going to use edge computing and fog computing for the actual end level assets. These kind of things are expanding, and even like the technologies like quantum computing, blockchains, assets performing its own transactions, etc. The OT/IT convergence is even more going to be a more stronger and deep topic for us. This is the same thing that we discussed on the earlier on the ISA 95. You see this the standard architecture or for integrating enterprise and control systems. So if you can see like the physical production processes in the L0 level, and we have the process control network and supervisory control applications. These are predominantly the SCADA application, the DCS, HMI apps, etc., which are there in the machine itself. And over and top of that, from L3, it is predominantly in the IT. So where we have the production apps, scheduling, the management apps, maintenance, and-on systems, etc. And the L4 and L5 is where we have the complete business architecture or ERP, CRM, etc. So the key stakeholders, if you see a OT/IT convergence, it is the complete factory itself, I would say. So we have the, of course, the industrial department, all the plant heads, supervisors, etc., the cyber security, the physical security team, the networking team, the IT and department, and all the people are involved in the complete OT/IT convergence, because all the inputs are required. Even if you take scenario of finance and HRM, why OT/IT is enabled is required by the sense of HR. We want to know like the productivity of certain resources, how much time they are logging in, logging out, what is the skill level, what is the quality level that they are achieving, identifying using modern scenarios like gamification to give benefits to the employees, etc. And finance level is of course key for cost control, for product costing, and as well as complete profitability of the entire factory. So all the departments are involved. Maybe some are involved at the planning and end user level. The main is like the maintenance department, and I would say the automation and controls department, and as well as the IT department, which comprising of the applications, networks, and systems. These are all the core enablers of OT/IT convergence. Again, we have seen this, like we are working on a complex environment. We are working at like a different teams are involved. Then scalability is very key, and IT is constantly evolving. The technologies that we use today are not the same, and cyber security is as well key aspect. So when we say OT/IT integration, there are three focus areas. One is data. What is the data that we are transferring? What are the technologies that are involved? And the security, how secure we are transferring the information. And competencies, who are the people involved, what competencies that they require. So the main objective of these focus areas is to create completely a proactive environment with focus on profitability, enabling digital continuity and learning management, with focus on metrics and rewards, and overall focus on cultural change rather than particular process or application implementation as core. So these are all like generic for any industry 4.0 or IoT, industrial IoT. So OT-IT convergence is a smaller part of the entire topic, but whatever is the benefits of the industry 4.0 or whatever the challenges that are there are similar to for OT-IT convergence as well. So when it comes to data, as I said, there are multiple assets that are involved. If you can see, these are only few in number that we have shown here, but there are many OEMs. Even if you take a small factory, there are a lot of different equipments. There are different manufacturers, and even in different manufacturers, there are different make and models. And for each type, there are different protocols involved, like the Modbus, MT Connect, Profibus. There are various when it comes to the protocol level, because there is like this particular technology is not from the beginning. So each region, each manufacturer has its own standard of publishing the information. So it is basically when we say a protocol, how the equipment is sending the data and how it can receive data, what formats are it being used, what messages it is structure it is being followed. And it is very important to have to collect all this information, because if we cannot have silos of applications. We cannot have like a application for say for Fanuc CNC machines, one for say like machines of another machines of Siemens drives, etc. But what we need is we are seeing the entire process as one. So we need one true source of information. And however, we also have all the IT systems which are either pushing data, like you say MES, uh, say if you are developing kind of a solution wherein you are giving a complete production schedule directly, job cards are being created for the manufacturer, and these job cards are say present on a tablet or the HMI of the machine, and this information is flowing from the ERP to MES and from MES to each machine. Then we need the information flow in that order as well. So we need to know which job cards, how, what are the production counts, etc. The machine or the HMI also needs to be capable to collect the information. And simple scenarios where most of us use is like say product checkout, when we are using a barcode based system to check out how many are what is the product flow across the entire factory. In that we are integrating say barcode readers with the ERP systems. That is again which is already prevalent, and there is one example of OT/IT convergence. And we have multiple things here. That's only the information that we are capturing here is like there are multiple protocols, multiple connectors, etc., multiple machines. All this information are generally it is advisable to fed through an edge server. So when we see the overall concept as of now is to have a separate OT network and a separate IT network. We create DMZs or demilitarized zones individually, and we are using strong firewalls to connect this OT IT network. So the data flow happens through a single channel, and what we call it as an edge server is a server that present on the site of factory, which collects all the informations. Depending upon the size of factory, we can increase the number of edge servers, but it can be ideally it is one server is enough for most of the factories. With that information we call it as like a store and forward. So store and forward is like the edge server collects all the information. So for a particular period of time, say for say 7 days, it has a capability to store the data for 7 days. So this way, what happens is the edge server, which collects the information, which sends it to the cloud server or on-premises IT server, even there's a network failure, the data can be retrieved for that particular period of time. So that is how the data is being stored and sent. And I want to touch upon the OPC UA. So OPC UA is like I said, when we are seeing the different manufacturer, different protocols are being used. So OPCUA is like the open source standard for exchanging data between industrial components and cloud on an unified architectures. There are different softwares like Kepware. There are some softwares developed by Bosch and Schneider, wherein these softwares, what it does is it is like trying to make it like a one tool for collecting all the information. So these particular softwares will have different protocol drivers. Like it can have a driver for Siemens, it can drive our Fanuc Focus, it can have for Heidenheim, etc., MD Connect, etc. With these drivers, the data is being collected. So all the data flow happens, even though from different machines, it is trying to pitch in through a common channel and collect the information, and it's sending to the IoT server or the cloud server. And extending the topic, the next focus area is security. So we saw about the OT security. Now we are seeing the IT OT security. It's like what are the components of it? Like these are the flow. These are the different equipments that are there, and how data flow is happening across from user to the application. And we have to enable like from the hardware level what security needs to be done, right from say simple like a password control, physical security of the hardware itself, etc. But in communications, how we are controlling it through access level encryption, enabling firewalls so that data flow is restricted. And if you are having a cloud or IT server, how we are securing that particular server, etc. And the entire thing is managed by a lifecycle management. When I say lifecycle management, it's more like to do a continuous risk assessment, enabling patches, or what we say, continuously improving the threat awareness of the entire systems. And we have to use complete assessment, how, and also the activity monitoring, etc., so that the entire life cycle is being completely monitored. We have what we saw is like a 360-degree monitoring of the entire assets on a regular basis. Coming to the competencies, so in traditional scenario, we would have somebody like who is like kind of expert in IT systems and expert in OT systems. Now, what we require is like a cross-functional experts, like IT roles which have OT competencies, the people who can understand the OT layer protocols, who can do a technical architecture on that, and also OT roles with IT competencies, say the robotics developers, the PLC programmers, automation specialists have a flavor of IT, because so that they can publish the information accordingly, they can understand the protocols, how data is communicated, etc. And there are also separate roles like the data scientist who process the data, cyber security experts, how what they need to do, and also on a holistic view, how the person business users, how they are using the data. So being said, we'll go to some scenarios how it is being implemented. So this is one example. Say take for example, there is a CNC machine. Here I believe the focus shown one is like having a Fanuc focus protocol. And what we do is we either directly we plug in the, if it has an Ethernet or a LAN port, we pop up, do a physical connection to an edge server. And in edge server, what we do is we install like software like Kepware, so which is like OPC UA protocol software. In that OPC UA protocol software, what we do is we define that particular asset. Say CNC machine A is what the asset we are defining, and then what we do is we choose the protocol, we choose the driver, and we give the what is the IP address it is being present. So the thing to be noted is there will be a physical connection. There will be a network level access from that machine to the edge server, and the access is enabled, and the IP addresses are available, and all the firewalls security is being taken care. Only when the edge server can say, I would say, network, in the network, if you can access a CNC machine, then it will show on the OPC UA software. There are two kinds of data collection here. Some of the scenarios, like uh, say certain protocols, certain controllers, they publish all the information that are available on the controllers. Like you need not define like each parameter wise. So once you connect and if you give scan for the available information, all the information that the original CNC programmer stored on that particular machine is available for the or the OPCUA software. So in that scenario, it is easy. So we can just collect all information, and only whichever data that we require, we can keep, and the rest we can ignore and save for later, and we can collect this information. On a second aspect, it is like the certain controllers do not publish all the information. So in that scenario, what we do is we have to know the particular address. So when I say address, if you take any CNC programming, they use various addresses to show various parameters. So it depends the type of address, the format, everything varies from controller to controller. Say for example, you can there is one for part count, there is one for whether it is running in manual mode or automated mode, or what is the speed, etc. All these are stored in certain addresses. You have to manually give the address and collect the information. So once we collect this information, we are just pushing it to the IoT or application server, and according to the application, the requirement, the usage happens. Here, say if you want to do an OEE calculation, what we need, we capture the part count, machine start time, machine running time, what is the cycle start time, cycle end time, etc. And with that, we can calculate the OEE, and depending upon the application, different things. Say scenario, if you are going to do a condition monitoring, you are monitoring the different conditions, the vibration, RPM, temperature, etc. So simply, this is the structure in which we follow to connect the edge server in this scenario. So this is a like direct one-to-one scenario. And next is you have a complex environment. There is conventional machines, there is non-conventional machines, there is SPMs. So here what happens is like uh, so so if the CNC machines, the process is similar to what I said earlier. But in scenarios like where there's a PLC or a controller that is not having an Ethernet connectivity, say for example, it has an RS485 connection or an RS232 connection, then you have a Ethernet converter. So this converter is nothing but a gateway device that will collect the information from the machine in certain format and publish it over either the format needed like TCP/IP, or it can be even a serial format. Over an Ethernet, it can publish to the edge server. And there are machines like what you see in the legacy machines. There is no controllers, or the controller is very outdated. So in that scenario, when we are collecting data, what we have to do is we are in this scenario, we are very cautious and very cost conscious on that. Whatever is the required information, very key, we collect those information alone. For example, if you want OEE, we put a sensor for part count. Then we put one sensor for machine start time and machine end time. It can be as simple as a on-off switch, etc. And this is all the external sensors that are added, which are put into a data acquisition module and all put it into a protocol converter, and this information is published to the edge server. So if you could see here, like one edge server talking to different kinds of one directly different kinds of information from the factory, collect it and push it through an access point to the application server across a firewall. And with the actual server, the actual applications are being hosted. The third is say certain complex CNC machines which don't allow access to the information, or it is like OEM locked. Okay, say certain, for examples, like say for example, this is one example which which is there, but which may not be present for all the users. Say for example, if it's a Mazak machine, it which typically uses an empty connect protocol. Suppose if the empty connect license is not available, this information is not published. So in that scenario, we have to either purchase the license or deploy edge level system, like a small micro PC with the empty connect agent on the system, actually, which will collect the information in empty connect to identify its empty connect is another protocol which publishes kind of like an XML kind of information and takes the information and push it to the client software. So when in the all the previous two scenarios, what you see is more on a physical level. We are connecting the information through like a gateway device or an Ethernet cable or sensors. Here we need to have like an edge level software itself, which is separate from the our OPC UA or data collection software. So for each machine, either we purchase a license or we collect this information and we take it. And the fourth is this, like it is over and top of this. Say we are putting more information on the IoT side, like we are monitoring the forklifts, we are monitoring say the visitor badge, we are having an RFID systems, we are using barcodes, we are using biometric scans, etc. We are using vibration sensors, etc. These are all like not on our typical production assets, but on like a process itself. So in that scenario, there is no controllers or PLCs that are there available. So we are putting some information, say like a GPS device, or we can putting like an RFID reader and scanner and an RFID converter, biometric reader, etc. In that again, we are collecting this information. Here, there are two approaches. One, uh, there are scenarios we collect the information, push it through edge server like a Kepware, etc. There are scenarios wherein we directly send it to the application layer. For example, the information is directly available over cloud or everything. We can directly push it to the application server itself. That is, it need not go through the edge server, but depends upon the network level and architecture level. We have to take the call on that. So these are the four high-level guides. There are scenarios, but there are even more complex scenarios that may be possible. For example, it may be different for an say this. I would say most of these scenarios which I touched upon are for discrete manufacturing systems. But if it goes to the let's take example of the process-oriented scenarios, it will be like we have to interface with the SCADA system itself, or we have to work with another end application, etc. There are also a lot of complex other scenarios, but for a give you an overview, I limit to these four scenarios. So the best practice is nothing but what we discussed earlier only. We have to do a current thorough understanding what is the current landscape, what are the equipment that are there, what is our goal. With that, we have to conduct the gap analysis. In the gap analysis, we have to say like what is not that from an investment perspective, what are the devices needs to be put, network perspective, etc. All the gap analysis we do, and then we have to take a call whether we are upgrading the hardware or excluding that particular hardware from for asset from the data collection process itself, etc. And then we are enabling the actual integration. Integration is key here. Why? Because see, most of the assets are like critical actual production assets. Uh, Collecting information require kind of planned downtime. So the entire downtime needs to be used properly, and scenarios has to be proper. Procedures have to be followed, because instead of collecting data which should not cause more downtime, etc., or we are putting the risk in entire machine itself at risk. Those kind of things should not be happening. And then once the data is collected, we have to validate the data. It should not be like, again, what it's happened is like, say if you are, uh, the tags have to be correctly mapped. For example, instead of start time, if some other parameter is mapped, it will give completely wrong data. So the entire data collection process has to be validated, and the network has to be verified. Proper connectivity is there, or we can see, and then focus on cultural change. That is all like how we use this data, etc. So that is that. And the key benefit of having a OT/IT convergence is primarily to have a simplified process control, to have a real-time visibility, and all the benefits of Industry 4.0 will have applicable for the OT/IT convergence here. And these are like what is happening in the IT/OT convergence. This is a recent slide from the November. So, like we discussed, the IT is coming to OT. So we are following an agile principle. We are following like DevOps is another concept wherein we are developing and operationalizing, which is in sync with agile, where we want to have modular systems. We say, for example, we, we the vendors need to update a certain package of the system, not the entire system. Like there are as a service concepts that are coming where the OT vendors are also talking about license access, etc. And then IT technologies. These are all like how, for example, whatever we see is current IT technology, how it is affecting the OT layer. So the OT vendors are coming up with low code applications, have enabling AI or data artificial intelligence on the edge level, working on some containerization, etc. And the IT and OT integrations, like IT applications have, like I said, we are at the edge, and OT applications are in the cloud. So wherein some vendors are using this, and if when we take about IT OT data, standard protocol converters are now being used. Many of them OT or OEMs are forming as part of some consortiums, or they're using this OPC UA protocol or MT Connect. All these there are quite a voice behind these consortiums to have a common theme and common language, and that together it has been very keen. And next is on the like we talked about the competencies, where we have need to have a collaborative teams which will handle all these, and cross domain training is needed. And when it comes to OT layers, even if you take the example, the hardware perspective, you can say like hardware software decoupling is happening. Say, for example, even in the current the Hanover message, we are able to see the rise of lot of virtual controllers. Say, instead of having one controller for each machine, there are the OEMs are coming up with a uh, common server which hosts multiple virtual controllers for each machines, so that it can be used with a very optimized way. And virtualization, one system running multiple operating systems, etc. And advanced computing, like we said, the fog computing, wherein the edge level analytics happen, and edge level analytics are shared with multiple machines, and based on that, prediction levels are being improved. Even quantum computing is also coming to the IT/OT convergence. So that is the overall. I wanted to give you overview. It's a very detailed topic. There are separate sessions for each of that which we discussed. But I would like to say, like, our this This webinar, we have touched upon what is OT, what is IT, what is the OT infrastructure, and what are the multiple protocols there, why we need modernization of OT, and how OT IT convergence happens, what is the principle of integration, focus on security, and the overall theme for not only OT IT convergence, but for any industry 4.0 successful implementation, it is to have like plan well, start small and scale big. Thank you for this opportunity, and maybe if you have any questions, we can discuss now.
Sabarinathan D. Yeah, hi.
Hi.
This is Rajesh. I would like to know one thing. Where the Maxbyte will play the role in this whole gamut of services? Whether you are a OT provider or you are a system integrator, which will actually build the solutions between our requirements and the IT technologies.
Okay. So, as a company, as a company, we are like an end-to-end provider. But that being said, uh, from the perspective of OT/IT convergence, we are more like a system integrator, and wherein we work with multiple companies like Siemens, Fanuc, and also gateway companies, etc. We understand. We do assessment of the complete factory OT infrastructure. We identify what are the different hardware needed, what can be the best source, etc. All that we do for our customers. To how we operate is like we also have a separate application portfolio. So we do for some scenarios we have done only like OT, IT, what convergence alone, and the customers are using their own applications. But most of our implementations have been like end to end. So we do the complete roadmap and implementation.
Okay, will you also help in setting up the requirements? Because as a business, we may not be pretty sure on the requirement what we have, like what and all technology can do for us. So if we request you to come and assess our current environment and suggest us a proper solution, will you do that?
Yeah, definitely. We have a different. We so on a day-to-day basis, we talk to multiple of the customers, understand requirements, give a not give the solution from the application standpoint as well as roadmap. We are also participating with agencies like National Skill Council, wherein we are assessing the factories. It's like on a so we are doing certain assessments for free, wherein we take the complete factory, we assess, we give them maturity roadmap, what they are, where they are, how they have to achieve the etc. So it can be, like I said, it can be for an individual application or all the over holistically for overall plant we can do.
Yeah, thanks.
Yes, I'll just drop my email
So
if you
will
require.
you be sharing the deck?
Sorry?
Will you be sharing the deck to the participants? Or if we ask you separately?
I
Because I
think
think
we will share it.
from the
We will share it through.
yes.
We will share it through the BCIC team, and I think they can publish it.
Okay, okay. Thank you, sir.
Yes, Mr. Giriraj.
Hello?
Yes, Mr. Sabarinathan.
Yes, madam. I think if there are no questions, we can just close. And I will share the presentation myself and our team will discuss and will share the presentation to you, which you can forward to the participants.
Yes, sure, sir. We will share it, sir. Any
Yeah,
questions from the participants? There are no questions, sir. Mr. Sabarinathan, can we close the session, sir?
Yes, madam. Yes, we have there any further questions? I have put
Yes.
my email, so you can drop the email and we can be glad to assist.
Yes, sir.
And thanks, BCIC team and Roopa madam, and also Chandramouli sir for helping us to give this session.
Thank you. Thank you very much, sir, once again for your insightful presentation. And once you share the deck, we will share it to our registered participants. And thanks to all the participants for your participation in the webinar. Thank you once again. Thank you all and have a good day.
Thank you.